Okay, so we have a basic PCB. In the most basic terms, will come as a two-layer PCB from a manufacturer. They will expect a two-layer PCB. And that's basically built up of many different layers. Normally it's in a material called FR4, which is a fiberglass PCB. And it comes with a core that sits in the middle. That is the bit that we kind of feel that gives it the strength. Either side of that core we have the top and the bottom. The first layer on top of that core will be a copper layer on both sides. So we have a top copper and a bottom copper. On top of that will be a solder mask. And a solder mask is the green thing that gets sprayed on there that stops the solder jumping across from one piece of copper to another. So it gives you like a kind of a barrier. So if you have lots of chips with very fine pitch pins and you're trying to solder them, quite often you put the solder in and solder will flow across them all and short them all out. If you can get solder mask in between those pins, that will prevent that from happening. So they spray a solder mask on top of the copper. And then on top of that solder mask, they will print an overlay, which is the text that you get on the PCB. And they'll put all this onto the board, press it all together, and give you an overall thickness of the board, which typically, the most standard, is 1.6 millimeters. So for this particular board here, it's a 1.6 millimeter FR4 process. 2 lots of copper, top and bottom, 2 lots of solder mask, top and bottom, 2 lots of overlay. Now, if we look on the drawing we have up here, this is actually referred to in Multisim on the left-hand side here as the layers. Let me just zoom that in a bit. So as you can see, up here we have copper top, copper bottom, which maps directly to what I've just drawn in that picture. Then we have a silk screen top, a silk screen bottom. That is the overlay on the top and the bottom. That's where we can print text. It's normally white in colour, but you can choose a colour. And we also have a solder mask top and bottom. And as you can see, that's the solder mask. So when I'm designing a PCB, I have to tell it what layer I want to put my geometry, my drawings, my lines, what layer I want to put that on. And then when that gets exported as a Java file, the production people will know exactly how I want that board to be built up. So this particular board here is very simple. It comes with a collection of surface mount components and a few through-hole components. So if we look here on the copper bottom, if I click on this copper bottom here, we can see that I've drawn a few traces on these through-hole components. You see these red lines? What that will do is that will tell the manufacturing company that I'm going to have those tracks on the bottom layer of the copper on the board. These green ones, however, they're actually on the top layer. So the manufacturing facility will etch those on the copper on the top layer of the board. And obviously, the top layer and the bottom layer are not connected in any way. There's no way of short circuiting because you've got that FR4 core in between the copper layers. So if I want to link a track from my top layer down to my bottom layer, I have to put what's called a veer in there. And what that is a little plated hole that they'll drill through. And then it will allow me to make a connection from the track on the top layer right through the board to the bottom layer. So I can pop that veer in. If you have a multi-layer board, you can tell it what layer you want it to start, what layer you want it to stop. But for this purposes, we've only got a 2-layer board. So it drills straight through, plates the hole, gives me like a connection through. All my surface mount components here, they're all placed on the top layer. They've all been routed on the top layer. And there's no way to access these. If I go to copper on the bottom layer, there's no way that I can make a connection to that pin because it's not through hole. It's actually sitting on the copper on the bottom layer. Sorry, on the top layer. So it will not make a connection to anything on the bottom layer. The only way I can get it there is to either use a veer or use a through-hole component. Every through-hole component, they drill a hole right through the board and they plate that hole. So it's like a veer on every leg of the through-hole component. So I can run a track on both sides to a through-hole component. Yeah? And then I can get a connection that goes through. Down here is an example. It's on the top layer here. this track, it hits this through-hole component, it goes through the plated hole of the through-hole component, and then comes out here in the red track on the bottom lap. Yeah, so the connection is via this through-hole component here. Then we have quickly talk about the solder mask. Normally you don't need to do anything on the solder mask, because what happens is when Multiboard or any PCB package places a component, they know that you've got a pad here. And this pad exposes a hole in the solder mask. So the fabrication plant will know that they can't spray the solder mask in this area because you need the copper exposed. Anywhere where you spray the solder mask, the copper will become hidden. So every time you need a pad or something, you need to expose that area in the solder mask. So that's, luckily for us in Multiboard, is done automatically for us, and it's represented by this colour, this green colour here. It's saying that, you know, in this area here, we have a solder mask exposure. So then we look at the silk screens. Silk screens or the overlay. What that is, we have the silk screen top and silk screen bottom, as I've drawn up there, and that is the text that you're going to print on your board. Now, in this case, every component has an identifier, an ident, or a designator. And that is this textual description, J4, J3, A1, J2. And in this case, as you can tell by the colour, these are all going to be printed on the top overlay. So when it comes back, you'll have lovely little bits of text, so you know where to put your things on the top overlay. And I can add my own text, as I've done here, on the top overlay. I've added a little picture here, done a little bit of rotation here. That is all going to appear on the top of the board. On the bottom of the board, I've also got some text. This is on the bottom overlay. When you put it on the bottom overlay, you have to mirror it. If you don't mirror it, it's going to be inverted when it comes back. Yeah? This is a common mistake. This happens a lot. Yeah? You'll find that you get your board back, you've muddled up in your mind what side of the board you're working with, and now suddenly every piece of text and identifier is mirrored.
Like yeah? It's showing 3D view.
Yeah. So if I point that onto the 3D. Okay, so we can see here, all this text is the right way around here. Yeah? If I turn this over, I can see now that I have the bottom there, and it's the correct orientation, yeah? Happy with that? Everyone can read it. The reason that's happened is because I've mirrored that text. And the reason I have to mirror it is because when you're designing in 2D, you're looking through the board. Yeah? You're not turning it around, you're looking through it. So I'm actually looking through the board to see this bottom overlay. And so, in my mind, if I turned this board around, that bottom would be the right way around. But all the others would be moved, wouldn't it? It's like spinning it around on the axis. So it's really important that, if you're going to place it, everything you design in 2D, you look straight through the board. So you've got to keep that in mind. If you put a picture or a piece of text, you've got to get it the right orientation. So the last thing I want to talk about is the board outline. Board outline is this yellow here, and that represents the actual physical shape of the board that comes back. Now normally if it's just a square or a rectangle, the manufacturing process can just what we call V-score it, and that puts a little V channel using a sharp disc through the board, and when it comes back you can snap it off really easy and you get perfectly straight edges. If you come along and decide, I want a lovely little notch or some special shape or something like that, it increases the production costs because now it needs to go to a routing process, where a routing machine will then come along with the tool and all around it. And what they will do is they'll miss a few little tabs around the board where they won't route, so it stays on the panel. And when you get that board back, you have to then pop it out the panel based on the tabs that are keeping that board inside the panel. But what it will do is it will allow you to do special effects like this. If I look at this on the 3D view again here, as you can see, we've got this lovely little notch in the board here. So to do that, it's very simple. You select the board outline, you delete the current board outline that you have, and then using the place tools, you can go down to graphics, and you can start putting in circles, ellipses, whatever you want, lines to create that board outline. Yeah? The important thing to remember about a board outline is that it has to meet. There has to be something that has continuation of all its sides somewhere. You can't leave a gap in the graphics. Yeah? Otherwise, what would happen is you'll end up with a whole panel because the machine won't understand that your board outline goes like this. If there's a gap there, it will suddenly give you the entire panel back and your production costs will skyrocket. So it's got to complete. It's got to start at one point, do whatever you want to do, and eventually come back to that same point. Yeah? Here we've got holes. Every PCB normally has got some kind of mounting hole or something along those lines. It's just something we have to consider every time you make a PCB. How is it going to be mounted in the final product? Is it going in a box? Is it going in some kind of kit assembly? Whatever. It needs to be thought about. In this case, I've placed 4 holes, and I can give them the radius of the hole, and I'm telling it that I need some space in the solder mask because I don't want the holes tinted. I don't want the solder mask to cover them. And what will happen then? I've told it as well that I don't want these plated. What that means is it's just going to be drilled through. There's not going to be any plating that goes on that connects the top layer to the bottom layer. Yeah. So it's just a hole that I can put a screw through, or put a foot, or some tip-on foot, or something like that. Here, this little bit here, this purple bit here, this is what I call a keep out. If you draw a keep out spot on a PCB, it will stop you from routing or stop any copper being poured in that area, including the trap that you physically placed. No copper will happen in that cutout area. What it basically does, I'll give you an example. When I do a ground pour on this device, so if I was to pour a power plate where I normally connect all the grounds together in a nice copper pour, if I place that on this device now, link it to a net. Okay, as you can see, I've poured that copper, and it's connected everything from net 0 together, as you can see here. The connection is made here. It's not made here. And it's also completely avoided my keep out area.